Hello friends, welcome back to my channel Maths by Samit Deshmukh. In this video we are discussing third part of question bank of differentiation, in which we are discussing the example which can be asked for how many marks? 2 marks. So if you are new on my channel, subscribe the channel and hit the bell icon to get notification of every newly uploaded video. So let us begin with the first example from the third part. In this case, our function is y is equal to log of cos of x raised to power 5, using which we have to find out dy by dx. So here we have considered the given function. Now we are differentiating it with respect to x. So dy upon dx is equals to find out the differentiation, we have to apply standard formulas. Now observe that this function is in the form of log f of x, isn't it? This whole term is nothing but f of x. And what is derivative of log f of x? 1 upon f of x. क्या है यहाँ पे f of x की value? Cos x raised to power 5 into derivative of f of x. f of x is what? Cos x raised to power 5, isn't it? So 1 upon, now keep this term as it is, cos x raised to power 5, keep it as it is. Now we are differentiating this function. To differentiate it, first we have to observe that the function is in the form of which standard formula. So here we can observe that this function is in the form of cos f of x, and what is derivative of cos f of x will be equals to minus sin f of x. f of x is what? X raised to power 5 into derivative of f of x, where f of x is nothing but x raised to power 5 here, isn't it? So now minus into plus will become minus. So here first write down sin x raised to power 5, and in the denominator write down cos x raised to power 5. Now we are differentiating this function, and it is in the form of x raised to power n. What is the derivative of x raised to power n? First take power as an coefficient, then decrease power by 1. So new power will be equal to 4. So here first write down 5, keep this minus as it is, then write down x raised to power 4, and here sin upon cos can be replaced by what? Tan x raised to power 5 will be the differentiation of this given function. Now see in the second example, here function is y is equal to under root tan root x, and here our aim is to find out value of dy by dx. So let us differentiate it with respect to x and see what derivative we are getting here with respect to x. So dy upon dx is equals to, here we can observe that the function is in the form of under root f of x. What is derivative of root f of x? 1 upon 2 root f of x. This term is nothing but f of x, that is tan root x into derivative of f of x, where f of x is what? Tan root x. So which is equals to, keep the first term as it is, 1 upon 2 under root tan root x. Now since we are finding differentiation of this function, we have to observe that the function is in the form of which formula? This function is in the form of tan f of x, and what is derivative of tan f of x will be equals to sec square f of x. क्या है यहाँ पे f of x की value? Root x into derivative of f of x means derivative of root x. Here sec square root x into 1 will be equals to what? Sec square root x. In the denominator 2 under root tan root x, keep it as it is. Now lastly we have to find out derivative of root x, and we know that derivative of root x is 1 upon 2 root x. So differentiation is completed. Remaining part is just simplification part. In the numerator sec square root x into 1 will be equal to sec square root x. In the denominator 2 into 2 will be equals to 4, and again we know that root a into root b can be written as what? Root ab. A is what here? X, and b is what here? Tan root x. In this way we have got the differentiation of this function. Now see the question number 3. In this question we have to find out the derivative of inverse function of y is equal to 2x cube minus 6x and calculate its value at x is equal to minus 2. So first one function is given to us, and we have to find out differentiation of its inverse function. Find the derivative of its inverse function, and we have one formula to find out derivative of what? Inverse function. So first applying that formula we are finding derivative of inverse function, but for that purpose we will require the derivative of what? Y, to apply that formula. Means that formula we have proved as a theorem. So here differentiate it with respect to x. So what we will get here, dy upon dx will be equals to, to keep it as it is, derivative of x cube will be equal to 3x square minus 6, keep it as it is, derivative of x is equal to 1, which is equal to 2 into 3, 6x square minus 6 will be the value of derivative. So we have one formula to find out derivative of inverse function, means dx upon dy will be equal to 1 upon dy upon dx. This theorem we are using specially to find out derivative of what? Inverse function. So here 1 keep it as it is. Now I am replacing dy by dx by its value 6x square minus 6. But question is to find out this derivative of inverse function at x is equal to, what? At x is equals to minus 2. At x is equal to minus 2. So on this side I am replacing x by minus 2. So 6 into minus 2 square minus 6. So which is equal to 1 upon, what is square of minus 2? 4. 4 into 6 is 24. 24 minus 6 will be equals to 18. So 1 upon 18 will be the value of derivative of inverse function at x is equal to what? Minus 2. In this way we have got our required value. Now observe the example number 4th. In this example, f of x is equal to x raised to power 5 plus 2x minus 3, and here also we have to find out derivative. Dash means what? Derivative of inverse function of f. Means example is similar to the last example, but here instead of x, value of y is given to us. Y is equal to what? Minus 3. This inverse function, derivative of inverse function at y is equal to what? Minus 3. That what we have to find out. So first we are finding derivative here to apply the theorem of differentiation. To find out the derivative of inverse function, we have one theorem, but to apply that theorem we will require the derivative of what? F of x. First let us try to find out this derivative. So here derivative of x raised to power 5 is 5x raised to power 4, and derivative of 2x will be equals to 2, and derivative of constant term will be equal to 0. So derivative is known to us. Now we are denoting this function say by y. So let y is equal to f of x is equal to x raised to power 5 plus 2x minus 3, because here value of y is given to us and our aim is to find out value of x, because this value of derivative is in terms of x, that's why we will require the value of x. So when y is equals to minus 3, here what we will get? Minus 3 will be equals to x raised to power 5 plus 2x minus 3. Minus 3 and minus 3 on both sides will get cancelled, means in short we can say that this minus 3 on this side will become plus 3. Plus 3 minus 3 will become 0. So remaining term means x raised to power 5 plus 2x will be equal to 0. From these two terms, if I am taking x common, so what will get here? X raised to power 4 plus 2 is equal to 0. Product of these two terms is 0, means either value of first term is 0 or value of second term will be equals to 0. So this implies that x is equal to 0 or x raised to power 4 is equal to plus 2 on this side will become minus 2. But we know that whenever the power of x is even number, at that time for any real number its value cannot be what? Negative. So here we can say that x raised to power 4 is equal to minus 2 is impossible. Impossible means we can say that x will be equals to 0. So this implies that x is equal to 0. Now we are applying our theorem. What is the theorem? We have one theorem to find out derivative of inverse function, means value of f inverse dash means derivative of inverse function of y will be equals to 1 upon f dash of x. So this is the formula to find out derivative which we have proved, derivative of inverse function which we have proved as an theorem. So here see what result we are getting. So f inverse dash of y will be equals to, now we are substituting the value of f dash of x, 1 upon, what is the value of f dash of x? F dash of x is equals to, here what we have got, 5 x raised to power 4 plus 2. So this, therefore value of derivative of f inverse at y is equal to, what is the value of y here? Minus 3, will be equals to 1 upon 5 x raised to power 4 plus 2, keep it as it is, plus 2, keep it as it is, at x is equals to what? At x is equals to, means what result we have got here? When value of y is equal to minus 3, at that time x will be equals to 0. At x is equal to 0, try to understand here. So at x is equals to 0 will be equals to 1 upon, now simply we have to replace x by 0. So if I am replacing x by 0 here, 0 raised to power 4 is 0, 0 into any number is 0, and 0 plus 2 will be equals to what? 2. So here we will get 0 plus 2 will be equals to 1 by 2. In this way we have got the value of derivative of f inverse at y is equals to minus 3 will be equals to 1 by 2. Means whenever the value of y is given to us, at that time using that value of y, we have to find out value of x, because value of derivative of f of x is in terms of x, and to find out the value of derivative we will require the value of what? X. Means whenever y is given to us, at that time this method we have to utilize to find out value of x. In the last example directly the value of x is given to us, so not necessary to use this method. लेकिन अगर यहाँ पे डेरिवेटिव की जो वैल्यू है इन टर्म्स ऑफ एक्स वाई मिलती थी, तो अब हमें x का इस्तेमाल करके कौन सी वैल्यू फाइंड करना ज़रूरी था? y की, यानी जब x की वैल्यू -2 है तो y की वैल्यू कितनी आएंगी ये भी फाइंड करना ज़रूरी था. लेकिन यहाँ पे डिफरेंशिएशन की वैल्यू इन टर्म्स ऑफ x है, इसलिए हमने y की वैल्यू फाइंड नहीं की, या y की वैल्यू y के वैल्यू की यहाँ पे कुछ ज़रूरत ही नहीं थी. दैट्स वाई वी हैव नॉट टेकन एफर्ट्स टू फाइंड आउट वैल्यू ऑफ व्हाट? y using value of x. Hope the difference between these two examples are very clear to you. In that example directly the value of x is given to us, but here value of y is given, but value of derivative is in terms of what? X. That's why using value of y we have seen how to find out value of x, and using this value of x we have got our required differentiation. Now see, in the question number 5, one inverse trigonometric function is given to us, y is equal to cos inverse of sine 4 raised to power x, and let us try to find out its differentiation. We have considered the given function. Now first it is possible here to simplify, so first we will simplify this function and later on we will find out its differentiation. So here, which is equal to cos inverse, keep it as it is. Now this function is in the form of sine, and here cos inverse appears, so we are trying to convert this sine in terms of cos so that we are able to apply property of inverse trigonometric function. अगर यहाँ पे cos inverse है तो यहाँ का एक्सप्रेशन भी cos में लाने की हम कोशिश करेंगे. फॉर दैट पर्पज वी आर अप्लाइंग अलाइड एंगल फॉर्मूला. सो व्हाट इज दैट अलाइड एंगल फॉर्मूला? sin theta can be written as cos pi by 2 minus theta, or you know that cos pi by 2 minus theta will be equal to what? Sin theta. So this sin theta can be replaced by cos pi by 2 minus theta, applying this formula. Here we have given the reason also. Applying this formula, since sin theta can be written as cos pi by 2 minus theta. Not necessary to use this formula in examination. Directly we are able to write down sin theta as cos pi by 2 minus theta. Just you should have to know which formula we have applied to get this result. That's why I have written here. So here, according to one of the property of inverse trigonometric function, cos inverse of cos theta will be equals to what? Theta. According to this property, here cos inverse and cos will get eliminated. Remaining term will be what? Pi by 2 minus theta, but sorry, here theta is nothing but what? 4 raised to power x. 4 raised to power x. Try to understand here. So this will be what? Sin theta, which can be replaced by cos pi by 2 minus theta. Theta is nothing but what? 4 raised to power x. After eliminating cos and cos inverse according to this property, here remaining term is pi by 2 minus 4 raised to power x. Now value of y is in the simplest form. Let us differentiate it with respect to x. So differentiate it with respect to x. So derivative of y is dy upon dx. Here derivative of constant term will be equal to 0, and this term is in the form of a raised to power x. Applying the formula of a raised to power x, is derivative is a raised to power x into log a, but here value of a is nothing but what? 4. So which is equal to minus 4 raised to power x into log 4 will be the value of dy upon dx. In this way we have got the value of dy by dx. Now see the question number 6. In this case, given function is y is equal to tan inverse of under root 1 plus cos x upon 1 minus cos x. Here also one inverse trigonometric function is given to us. We have to find out its derivative. So we have considered this given function. So before finding its differentiation, let us simplify it. Here tan inverse is there. So that's why simplifying this expression, we are trying to convert it in terms of tan, so that tan and tan inverse will get eliminated according to property of inverse trigonometric function. So now let us simplify this expression. It is numerator is in the form of 1 plus cos theta. So we are able to apply here half angle formula. What is the value of 1 plus cos theta? 2 cos square theta by 2. Theta is here x, so x by 2. And in the denominator 1 minus cos theta is 2 sin square theta by 2. Theta is here x. Again 2 will get cancelled. Tan inverse of, so which is equals to tan inverse of, here cos square x by 2 upon sin square x by 2 will be equals to what? Cot square x by 2, because we know that cos upon sin is equal to cot. So cos square upon sin square will be equals to what? Cot square. So which is equal to tan inverse, keep it as it is. Here square and root will get cancelled, means remaining term will be what? Cot x by 2, or we can say that square root of cot square x by 2 is cot x by 2. Now here we can observe that this expression is in terms of cot. We have to convert it in terms of what? Tan. To convert it in terms of tan, apply allied angle formula. According to allied angle formula, cot theta can be replaced by tan pi by 2 minus theta. Theta is what here? X by 2. We know this allied angle formula, tan pi by 2 minus theta is equal to cot theta, means cot theta can be written as tan pi by 2 minus theta. Now after cancelling tan and tan inverse, what we will get? Pi by 2 minus x by 2. We are able to eliminate these two, tan inverse and tan, using which property? Since tan inverse of tan theta will be equals to what? Theta. So here given function is now in the simplest form. So let us differentiate it with respect to x. So derivative of y with respect to x is dy upon dx. On this side derivative of constant term is 0, and here derivative of x is 1. So here remaining term is minus 1 by 2. So this implies that dy upon dx will be equals to minus 1 by 2. In this way we have got our required derivative. Now see, in the 7th example, given function is parametric function, x is equal to sin theta and y is equal to tan theta. Using this we have to find out dy by dx. So to find out dy by dx in case of parametric function, we have proved one theorem. So let us make the use of that theorem. So dy upon dx can be written as dy upon d theta. Why we are differentiating with respect to theta? Because in this case theta is the parameter, and in the denominator what will get? Dx upon d theta. Just simply we are differentiating y and x both with respect to theta to find out value of dy by dx. This is nothing but one of the theorem which we have proved. So which is equal to, now just remaining part is to substitute the value d by d theta, keep it as it is. Y can be replaced by its value tan theta, and here d by d theta, keep it as it is. X will get replaced by its value sin theta. So let us see what we will get here. So in the numerator derivative of tan theta will be equals to what? Sec square theta, and in the denominator derivative of sin theta will be equals to cos theta. So in the numerator keep sec square theta as it is, and what is reciprocal of cos? Reciprocal of cos is what? Sec, and sec square into sec theta will be equal to sec sec cube theta. In this way we have got the value of dy by dx will be equal to sec cube theta. Now observe the next example. In the example number 8, this is the given function. We have to differentiate it with respect to x. If you will observe here term of inverse trigonometric function appears. That's why we are trying to simplify it using the property of inverse trigonometric function. So we have considered this function and we have denoted it by y. So here this expression, can I write this square? We are able to write here also. So what is the remaining term here then? Sine inverse of x square, isn't it? Sine inverse of x square. We have one property that sine inverse of x, sine inverse of x will be equals to what? X. According to this property, we can say that sine and sine inverse will get eliminated and we will get what? X. So here, if we are applying this property here, we will get x square. Keep this raised to power 2 as it is. Just simply sine and sine inverse will get eliminated according to this property. And here remaining term is x square and keep this square as it is. What is square of x square will be equals to x raised to power 4. Now our y is in the simplest form. Now we are differentiating it with respect to x. So differentiate it with respect to x. So derivative of y will be denoted by dy by dx, and on this side apply which formula? X raised to power n. According to this formula, find out differentiation means take power as an coefficient and decrease power by 1. In this way we have got the value of dy by dx. Now we are starting fourth part of this question bank, means we are discussing the example which can be asked for what? 3 marks. So see, in the first example, one function is given to us, y is equal to log of under root 1 minus cos 3x by 2 upon 1 plus cos 3x by 2, and question is to find out its differentiation. So we have considered this function. Now we are trying to simplify it, and later on we will try to find out differentiation. So which is equals to, keep this log as it is. We have already studied about half angle formulas. According to half angle formulas, 1 minus cos theta can be written as what? 2 sine square theta by 2. What is theta here? 3x by 2, and divided by 2. If we are dividing, because theta by 2, we are trying to find out value of theta by 2. After simplifying, what we will get? 3x, and 2 into 2 will be equals to 4. Means this is the value of what? Theta by 2. So here we are using half angle formula, so that's why we will require the value of theta by 2. Again see which formula we are applying. 1 minus cos theta is equal to 2 sine square theta by 2. Theta is here 3x by 2, and it's, if we are taking its half, then we will get 3x by 4. Same method we are applying in the denominator. In the denominator, which formula we are applying? 1 plus cos theta, and according to half angle formula, value of 1 plus cos theta is equal to what? 2 cos square theta by 2. Here theta is 3x by 2, so its half is 3x by 4. So which is equal to, again it can be simplified. So here 2 will get cancelled, under root keep it as it is, sine square theta upon cos square theta can be written as tan square theta, where theta is 3x upon 4. So which is equal to log of the square and root will get cancelled, and what we will get here? Tan 3x by 4. Now we have converted y in the simplest form. Now nothing is there to simplify, and already the term is in the standard form, log f of x. So we are able to differentiate it applying the formula of differentiation. So differentiate it with respect to x applying our standard formula. So derivative of y will be dy upon dx. On this side, derivative of log f of x will be 1 upon f of x. F of x is what here? Tan 3x by 4 into its derivative, into derivative of tan 3x by 4. So here keep this term as it is. Otherwise reciprocal of tan will be equals to what? Cot 3x by 4. Now we are finding its differentiation. If you'll observe here, this term is in the form of tan f of x. What is derivative of tan f of x? Sec square f of x. Sec square f of x. What is f of x? 3x by 4 into derivative of 3x by 4. So means we are applying which standard formula? Tan f of x. So its derivative is sec square f of x into derivative of f of x. Now we are trying to simplify it. Cot can be written as cos upon sine. So cos 3x upon 4 divided by sine 3x upon 4, and this sec can be written as 1 upon cos, so sec square can be written as 1 upon cos square 3x by 4. Just simply sec square theta can be written as 1 upon cos square theta. All of you know this interrelation to find interrelation between trigonometric ratios. Now here we are finding derivative. What is derivative of x? 1, and 1 into 3 by 4 will be equal to 3 by 4. So differentiation is completed. Differentiation of last term is also known to us. Now remaining part is just simplification part, so which is equals to, so now here this cos 3x by 4 and 1 cos 3x by 4 from denominator will get cancelled. So check what result we are getting here. So here we will get sine 3x by 4 into, after cancelling cos, here remaining term is what? Cos 3x by 4, because one term of cos from this cos square will get cancelled with this term. So into this 3, keep it as it is. This 4, can I write it as 2 into 2? Simply this 4 can be split up as 2 into 2. Why we are writing it in this form? To convert or to arrange this term in the form of double angle formula. So we are trying to arrange it in the form of 2 sin theta into cos theta. So 2 sin theta into cos theta is the value of what? Sin 2 theta. So to arrange the term in the form of double angle formula, just simply 4 can be written as what? 2 into 2. So which is equal to, so here 3 into 1 is 3. In the denominator, see, 2 sin theta into cos theta is sin 2 theta. Theta is what? 3x by 4. And if we are multiplying to it by 2, so what we will get? 2 2s means what we are getting? 3x by 2. So 3x by 2 is the value of what? 2 theta, because 2 sin theta into cos theta is sin 2 theta. Theta is 3x by 4, so its twice is 3x by 2. So this is the value of what? Sin 2 theta according to double angle formula. Keep this 2 as it is. So I am writing this numerical value here. So this 2 I have written here, and value of this whole term is sin 3x by 2. So now already we have converted it in the simplest form. So keep this 3 by 2 numerical value as it is. So this this sign, if we are shifting it in the numerator, means if we are taking reciprocal of sine, we will get what? Cosec. So cosec 3x by 2, and this is the differentiation of this function. Now see in the second example, what is the given function? Y is equal to log of 4 raised to power 2x into x square plus 5 upon under root 2x cube minus 4 raised to power 3 by 2. Means here easily we can observe that the function is logarithmic function, and logarithmic function before finding differentiation can be simplified using laws of logarithm. So let us first consider this function and simplify it applying laws of logarithm. So which is equals to, so here we can observe that the terms are in the form of log a into b, log a into b. So according to laws of logarithm, it can be written as log a plus log b. And what is b here? B is x square plus 5 divided by under root 2x cube minus 4 raised to power 3 by 2. Just simplify it using laws of logarithm. Log a into b can be written as log a plus log b. Now again we are simplifying it applying laws of logarithm. So which is equals to, just I am writing here. So according to laws of logarithm, this power can be taken as coefficient. 2x can be taken as coefficient into log 4. Plus here also according to laws of logarithm, this 3 by 2 power can be taken as what? Coefficient, and remaining term will be log of x square plus 5 divided by under root 2x cube minus 4. Okay, so already the first term is in the simplest form, so keep it as it is. So 2x into log 4, keep it as it is, plus 3 by 2 also as it is. Now again according to laws of logarithm, this term can be simplified, and here which law can be applicable? Log a upon b. Log a upon b can be written as log a minus log b. So see what we will get? Log a means what here? X square plus 5 minus log b. B is what here? Under root 2x cube minus 4. Just we are simplifying, applying which law? Log a upon b can be written as log a minus log b. So which is equals to, so here 2x into log 4, keep it as it is, plus 3 by 2 also as it is. Now here nothing is there to simplify, so keep the first term as it is, log of x square plus 5 minus. Now here under root can I consider as raised to power 1 by 2, because we know that root x can be written as what? X raised to power 1 by 2. Means what is the power of 2x cube minus 4 will be 1 by 2, and according to laws of logarithm that power can be taken as coefficient. So here 1 by 2 we are taking it as an coefficient, here log of 2x cube minus 4, keep it as it is, isn't it? So now the whole expression is in the simplest form. So we have simplified the given function applying laws of logarithm. Now we are finding its differentiation. So differentiate it with respect to x. So see what differentiation we are getting here. On this side, derivative of y will be equals to dy upon dx, and on the right hand side, see here three terms are there, first, second and third. Three terms are there, and we are finding differentiation of all these three terms, applying addition, and somewhere subtraction is there, means we have to apply addition and subtraction formula. In case of first term, 2 and log 4 is a constant, keep the constant as it is. What is derivative of x? 1. So 1 into 2 log 4 will be equals to 2 log 4, means differentiation of first term is 2 into 1 log 4, where 1 is nothing but differentiation of what? X, plus this 3 by 2, keep it as it is. Now we are finding differentiation of second term. So it is in the form of log f of x. What is the derivative of log f of x? 1 upon f of x. What is f of x here? X square plus 5 into its derivative, into derivative of x square plus 5, isn't it? Keep minus 1 by 2 as it is, minus 1 by 2 as it is, and here this term is also in the form of log f of x. Again find out its differentiation applying the formula of log f of x. So its derivative is 1 upon f of x. F of x is 2x cube minus 4 into its derivative, into derivative of 2x cube minus 4, isn't it? In this way we have got differentiation. Again some terms of d by dx is there, so let us simplify it and see what result we are getting. Here 2 into 1 is 2 log 4, keep this first term as it is, 2 log 4, plus here 3 by 2, keep it as it is. Let us try to find out differentiation of this term. Differentiation of x square is 2x and derivative of 5 is 0, means differentiation of this whole term is 2x, and 2x into 1 will be equal to 2x. 2x upon x square plus 5. Here minus 1 by 2, keep it as it is. Now we are finding differentiation of this term. So try to understand. Differentiation of x cube is 6x square, isn't it? 3x square. 3x square, 3 into 2 will become what? 6, means differentiation of whole term is 6x square divided by 2x cube minus 4, keep it as it is. Now differentiation of every term is known to us. Remaining part is just to simplify it wherever simplification is possible. 2 log 4, keep it as it is. If I am multiplying by 3 by 2 to first term in this bracket, 2 and 2 will get cancelled. What is the remaining term? 3x divided by x square plus 5. Just simply I am multiplying by 3 by 2 to first term. If I am multiplying by 3 by 2 to second term, what we will get here? Minus here 3 into 6 will be 18x square, and in the denominator 2 into 2 will be equals to 4 into 2x cube minus 4. Just simply I have multiplied by 3 by 2 to both the terms, first term also and second term also. So which is equal to 2 log 4, keep it as it is, plus 3x divided by x square plus 5 also as it is, minus here both the numbers are divisible by 2. So 2, if I am dividing to numerator by 2, 2 9s are 18, and if I am dividing to denominator by 2, so here we will get 2 into 2x cube minus 4. In this way we have got the differentiation of this function. Now see the third example. In this case one inverse trigonometric function is given to us and we have to find out its differentiation. So we have to differentiate it with respect to x. So which is equals to, now here cot inverse appears here. So simplifying this trigonometric expression, we will try to convert it in terms of what? Cot inverse, so that we are able to apply the property of inverse trigonometric function. Using that we are able to eliminate cot inverse and what? Cot. But for that purpose we have to convert this expression in terms of cot. So here numerator and denominator can be simplified applying half angle formula. So what is the value of cos theta? cos theta is equal to cos square theta by 2 minus sin square theta by 2. Applying that formula, cos x can be replaced by cos square x by 2 minus sin square x by 2. Just simply we are applying half angle formula. In the denominator also apply the half angle formula. 1 plus sin theta can be written as cos x by 2 plus sin x by 2 whole bracket square. Just in the numerator also and in the denominator also we have applied half angle formula. Cos x can be replaced by cos square x by 2 minus sin square x by 2, and 1 plus sin x can be replaced by cos x by 2 plus sin x by 2 whole bracket square using half angle formulas. Now let us simplify it. So which is equal to, keep this cot inverse as it is. Now here in the numerator, terms are in the form of a square minus b square. So what are its factor? A plus b into what? A minus b. A plus b. A means what here? Cos x by 2 plus b. B means what? Sin x by 2. So a plus b into a minus b. A minus b means cos x by 2 minus sin x by 2. Isn't it? Just we have got the factors of this expression applying which identity? A square minus b square is equal to a plus b into a minus b. Keep the denominator as it is. Denominator is what? Cos x by 2 plus sin x by 2 whole bracket square, isn't it? So which is equals to cot inverse, keep it as it is. Now here we can observe that this cos x by 2 plus sin x by 2 and one term of cos x by 2 plus sin x by 2 from the square will get cancelled. After cancelling cos x by 2 plus sin x by 2 from numerator and denominator, remaining term in the numerator will be cos x by 2 minus sin x by 2, and in the denominator cos x by 2 plus sin x by 2, isn't it? So which is equals to cot inverse, keep it as it is. We are simplifying it in such a way that this expression will get converted in terms of what? Cot. Now I am dividing to numerator and denominator by cos x by 2. Let us see what we will get. So if I am dividing to numerator by cos x by 2, cos x by 2 upon cos x by 2 is 1 minus sin x by 2 upon cos x by 2 is what? Tan x by 2. Just I am dividing to numerator and denominator by what? Cos x by 2. So if I am dividing here by cos x by 2, we will get 1, and here sin upon cos will become what? Tan x by 2. This result we have got simply dividing to numerator and denominator by what? Cos x by 2. If you want, write down here, divide numerator and denominator by cos x by 2, we get. Let us see what we will get. We will get this result. Now again let us simplify it. So here on this side y, keep it as it is. Here write down cot inverse. This 1 can I replace it by tan pi by 4? Yes, value of tan pi by 4 means tan 45 is 1. Keep the second term as it is, tan x by 2 as it is. In the denominator, 1 keep it as it is, plus also as it is. Now here nothing is the coefficient of tan x by 2 means 1 is there, and 1 can be written as what? Tan pi by 4 tan 45 into tan x by 2, keep it as it is. Hope you all got it. So which is equals to, here we are just simply trying to arrange the term in the form of tan a minus tan b upon 1 plus tan a into tan b, where a is pi by 4 and b is what? X by 2. Now this is nothing but formula of what? Tan a minus b. A is what here? Pi by 4, and b is what here? X by 2. So in this way we have converted this expression in terms of tan. Once the expression will get converted in terms of tan, easily we are able to convert it in terms of cot applying allied angle formulas. So here cot inverse, keep it as it is. So we know that tan theta can be written as cot pi by 2 minus theta, or in other word we can say that cot pi by 2 minus theta is equal to what? Tan theta. So using this result, this tan theta can be written as cot pi by 2 minus theta. What is the value of theta here? Pi by 4 minus x by 2. Applying this formula, just simply we have converted this tan in terms of what? Cot. So which is equal to, now according to our one of the property of inverse trigonometric function, cot inverse of cot theta will be equals to what? Theta. Means this cot inverse and cot will get eliminated. So after eliminating cot inverse and cot, let us simplify the remaining expression. Remaining expression is pi by 2 minus pi by 4, and minus into minus will become plus x by 2, isn't it? So here pi by 2 minus pi by 4 will be pi by 4 plus x by 2. So this is the value of y in the simplest form. Now differentiate it with respect to x. So differentiate it with respect to x. Derivative of y is dy upon dx. On this side, derivative of constant term is 0. Derivative of x is 1. So and its coefficient is 1 by 2. 1 into 1 by 2 will be equals to 1 by 2. So which is equal to 1 by 2. Means here we can say that dy by dx will be equals to 1 by 2, which is nothing but differentiation of this given function. Now see, in the example number 4th also one inverse trigonometric function is given to us. Let us try to find out its differentiation, but before that let us simplify it. Here we can observe that sine inverse is there, so we are trying to convert this expression also in terms of sine. So here keep this sine inverse as it is. See how to convert this expression in terms of sine here. So here divide to both the terms separately by root 13. So here we will get 2 upon root 13 into cos x, plus here we will get 3 upon root 13 into what? Sin x. Just simply we are dividing to both the terms separately by what? Root 13. So now here we can observe that the two numbers we have got, their sum of square will be equals to, so square of 2 upon root 13 plus square of 3 upon root 13 will be equals to, in the numerator square of 2 is 4, here square of 3 is 9, and square of root 13 is 13. So since denominators are same, so we have taken addition of numerator. So 9 plus 4 plus 9 is 13. 13 upon 13 will be equals to 1. Means here what is our conclusion? Sum of square of these two number is 1. ये दोनों नंबर के स्क्वायर की एडिशन 1 है. और ऐसे कौन से ट्रिग्नोमेट्रिक फंक्शंस है या ट्रिग्नोमेट्रिक रेशियोज है जिनके स्क्वायर की एडिशन 1 है? साइन एंड कॉस. वी नो दैट साइन स्क्वायर थीटा एंड कॉस स्क्वायर थीटा इज इक्वल टू 1. मींस वी कैन से दैट दीज टू नंबर्स सैटिस्फाइज व्हिच आइडेंटिटी? साइन स्क्वायर थीटा प्लस कॉस स्क्वायर थीटा इज इक्वल टू 1. तो अगर मैंने इसे साइन से डिनोट किया तो इसे हम कॉस से डिनोट कर सकते हैं, क्योंकि साइन और कॉस के स्क्वायर की भी एडिशन 1 है और ये दोनों नंबर के भी स्क्वायर की एडिशन क्या है? 1 है. तो इसे अगर साइन से डिनोट किया तो इसे कॉस से करना पड़ेगा, और इसे कॉस से किया तो इसे साइन से. अभी हमें ये एक्सप्रेशन साइन में कन्वर्ट करना है. एंड व्हाट इज द फॉर्मूला ऑफ साइन? साइन ए इंटू कॉस बी प्लस कॉस ए इंटू साइन बी. तो ये साइन है, साइन ए अगर इसे कंसीडर किया तो ये क्या होना चाहिए? कॉस. सो साइन ए इंटू कॉस बी प्लस कॉस ए इंटू साइन बी, साइन ए प्लस बी. तो फिर साइन और साइन इनवर्स क्या हो जाएगा? कैंसल अकॉर्डिंग टू प्रॉपर्टी. सो दैट्स व्हाई वी आर डिनोटिंग दिस नंबर बाय व्हाट? by sine and this number by cos. So let us denote this number by what? Sine. So sine theta is equals to 2 upon root 13 and cos theta is equals to, cos theta is also equals to what? 3 upon root 13. So which implies that tan theta is equals to, if we are taking their division, sine upon cos is tan. On this side if we are taking division, root 13 will get cancelled. We will get 2 by 3. So which implies that theta is equal to tan inverse of what? 2 by 3. So these are the result which we are getting according to our supposition. Means what is our supposition? Denote this value by sine and this value by cos. Now substitute all these value in this function and let us see what we will get here. Now we are substituting the value of 2 by root 13 is equal to sine theta. So therefore y will become, so y will be equals to sine inverse of, so what 2 by 13 can be replaced by cos theta. 2 by 13 can be replaced by sine theta. Sorry, it will be replaced by what? Sine theta into cos x, keep it as it is, plus 3 by root 13 can be replaced by cos theta. Cos theta into what? Sin x. So which is equals to, keep this sine inverse as it is. Now we are writing this expression as Sin x into cos theta. First write down this term, sin x into cos theta, plus then write down cos x into sin theta, cos x into sin theta. Just we are trying to arrange the term in the form of sin a into cos b plus cos a into sin b. So which is equals to, which is nothing but value of what? Sin a plus b. Sin a is what here? X, and b is what here? Theta. So now according to our property of inverse trigonometric function, sin inverse and sin will get eliminated. What is the remaining term? X plus theta. So this is the value of y. So y is equal to x plus theta. Theta is what here? Tan inverse of 2 by 3. Now we are differentiating it with respect to x. So differentiate it with respect to x. So dy upon dx will be equals to, derivative of x is 1, and is it a constant term? Yes, it is a constant term because x does not appear in this term, means variable does not appear. So we can say that it is a constant term, and we know that derivative of constant term is 0. So which implies that dy upon dx will be equals to what? 1. So in this way we have got the differentiation of given function. Now see the example number 5. In this case we have to differentiate this inverse trigonometric function with respect to x. We have denoted this function by y, and what is the function? Tan inverse of 8x upon 1 minus 15x square. So here we are trying to arrange the term in the form of this property, that tan inverse of x minus y upon 1 plus xy can be written as what? Tan inverse of x minus tan inverse of y. So to arrange the term in the form of this property, in the denominator minus is there. अगर यहाँ पे minus है तो यहाँ पे plus होना चाहिए, तो यहाँ पे plus आएगा हमारा. So we are trying to arrange the term in the form of this property. So here we have to find out factors of 15x square. किसके factor चाहिए हमें? 15x square के. जो भी factor मिलेंगे उनकी addition कहाँ पे होनी चाहिए? Numerator में. तो यहाँ पे हम factor गिराने की कोशिश करेंगे. So let us try to find out factors of what? 15x square. So 15x square can be written as 5x into 3x. 5x into 3x will be equals to what? 15x square. And check that addition of these two factors, is it equal to 8x? Yes, 8x means 8x can be written as 5x plus 3x. Just simply we are trying to arrange the term in the form of this property. Now check that in the numerator 8x is there. 8x can be split up as 5x plus 3x. 5x plus यहाँ पे दो terms की addition होनी चाहिए, और ये दोनों का product यहाँ पे होना चाहिए. That whatever may be x and y we have got here, their product should be here, and the denominator first term should be 1. Already 1 is there, minus is also there, and yes, product of these two terms is this one, means what? 15x square. Now the terms are exactly form of this property. That's why according to this property it can be written as tan inverse of 5x plus tan inverse of 3x. Now easily we are able to find out differentiation. So differentiate it with respect to x. So derivative of y is dy upon dx is equals to, now the first term is in the form of tan inverse of f of x. So its differentiation is 1 upon 1 plus square of f of x into derivative of f of x. What is f of x here? 5x. Using same method we are finding differentiation of second term. What is second term? It is in the form of tan inverse of f of x. So its derivative is 1 upon 1 plus square of f of x into its derivative, into derivative of 3x. So which is equals to, what is derivative of 5x? Will be 5. 5 into 1 will be equals to 5. In the numerator we are getting 5, and in the denominator square of 5 is 25 and square of x is x square, plus here derivative of 3x is 3. 3 into 1 is 3, and in the denominator 1 plus square of 3 is 9 and square of x is x square. In this way we have got the differentiation of the given function. Now see the example number 6. In this example, one logarithmic function is given to us, and we have to show that dy by dx is equal to 12x cube upon 13y cube. So we have considered the given logarithmic function. Now we are simplifying it, and we will try to get our required result. So here, to simplify it, we should have to know the definition of logarithm. Suppose that one exponential form is there, a raised to power x is equal to b. Then this exponential form, using definition of logarithm, can be converted in logarithmic form as log of b to the base a is equal to what? X. Means value of logarithm is nothing but what? Exponent. Okay, so as it stand, so here this is called exponential form and this is called as logarithmic form. Means exponential can be converted in terms of logarithmic, or logarithmic form can be converted in terms of exponential form using this definition of logarithm. So as it stand, here expression is in the logarithmic form, we have to convert it in terms of exponential form. चलो अभी देखो ये x means what? Exponent. What is exponent? 2. A means what? Base. What is the base here? 5. So on this side we will get 5 square. तो ये base है a और ये x क्या है? Exponent. So ये यहाँ पे base 5 है और exponent 2 हो गया according to this definition. So on this side we will get 5 raised to power 2, and b means what? Log of whatever may be the log of. What is the value of b here? Log of b means log of b. So this is b here, x raised to power 4 plus y raised to power 4 upon x raised to power 4 minus y raised to power 4, means b is equal to a raised to power x. b is equal to a raised to power x. We have simply converted logarithmic form in terms of exponential form, applying this definition of logarithm. Now let us simplify it. In the numerator, x raised to power 4 plus y raised to power 4, keep it as it is. And on this side, square of 5 is 25, and this term will get multiplied to 25, x raised to power 4 minus y raised to power 4. So here x raised to power 4 plus y raised to power 4, keep it as it is. I am multiplying simply by 25 to both the terms in this bracket. So 25 into x raised to power 4 is 25 x raised to power 4, and here minus 25 into y raised to power 4. Now on one side collect the terms of y raised to power 4 and another side collect the terms of x raised to power 4. This minus 25 y raised to power 4 on this side will become plus 25 y raised to power 4. 25 y raised to power 4 plus y raised to power 4 is 26 y raised to power 4. On this side 25 x raised to power 4, keep it as it is. This plus term on this side will become minus. 25 x raised to power 4 minus x raised to power 4 will be 24 x raised to power 4. Easily we can observe that both the sides are divisible by what? 2. So if I am dividing both sides by 2, here we will get 13 y raised to power 4, and on this side we will get 12 x raised to power 4. Now the given expression is in the simplest form, so we are differentiating it with respect to x. On this side 13 is a constant term, keep it as it is. We are finding derivative of y raised to power 4. So first take power of y as an coefficient, decrease its power by 1 into derivative of y is dy by dx. On this side 12, keep it as it is. Let us try to find out derivative of x raised to power 4. First take power as an coefficient, decrease power by 1. So 4 and 4 on both sides will get cancelled. This implies that dy by dx will be equals to, what is the term, remaining term here, 12x cube, and here coefficient of dy by dx is 13y cube. So 13y cube is multiplied on this side it will get divided. So 13y cube will get divided on this side, and which is nothing but our required derivative. dy by dx is equal to 12x cube divided by 13y cube. In this way we have got our required result. Now see the example number 7th. In this case, given function is y is equal to under root cos x plus under root cos x plus under root cos x, continuing this way. Such type of how many terms are there? Infinite terms are there, and we have to show that dy upon dx is equal to sin x upon 1 minus 2y. So we have considered the given function. Now first we are simplifying this given function, and later on we will find out its differentiation and we will try to get our required result. So here y, keep it as it is. So which is equals to, now observe the given expression in very proper way. So keep first term as it is, cos x. Now observe here, if I am excluding this term, so observe the remaining expression. Is it exactly in this form? Yes, under root cos x plus under root cos x plus under root cos x plus under root cos x, up to what? Infinity. Means this whole expression is exactly in this form. So which can be replaced by what? Y. So plus minus y. Hope you have got it. This whole expression is also exactly same expression, and its value is equal to what? Y according to given condition, isn't it? So can be replaced by y, because this expression we have denoted by y. So now we are squaring both sides. Let us see what we will get. Square on both sides. We get, let us see what we will get if we are squaring this side. Left hand side will get y square. On the right hand side, if we are squaring, square root will get eliminated, so means remaining term is cos x plus y. Now plus y on this side will become minus y, so on this side y square, keep it as it is, plus y will become minus y. On this side remaining term is cos x. Now since the given expression is in the simplest form, so we are differentiating it with respect to x. So derivative of y square with respect to x is 2y minus derivative of y square is 2y, and derivative of y is dy by dx, minus derivative of y is dy by dx, and on this side derivative of cos x will be equal to minus sin x. Now two terms of dy by dx we have got here. We are taking dy by dx common from these two terms. If we are taking dy by dx common from first term, so here remaining term is 2y, and here remaining term is what? Minus 1. Means 2y minus 1 dy by dx is equal to minus sin x, which implies that dy by dx is equal to, keep this minus sin x as it is, this term will get divided on this side, that is 2y minus 1. But if you observe our required result here, minus is not there, means to get our required result, simply if we are multiplying to numerator and denominator by minus, we will get our required result. Means dy upon dx will be equals to, see what we will get if we are multiplying to numerator by minus, here minus into minus will become plus, means plus sin x, and in the denominator if we are multiplying by minus, this negative term will become positive and this positive term will become negative. Simply this result we have got by multiplying to numerator and denominator by what? Minus, which is nothing but our required value of dy by dx. Now see the question number 8. In this question, we have to differentiate cos inverse of x with respect to under root 1 minus x square. So I am denoting cos inverse of x by u and under root 1 minus x square by v. So we have to differentiate cos inverse of x by what? Under root 1 minus x square. But now cos inverse of x means what? U, and under root 1 minus x square means what? V. Means in other word, can I say that we have to differentiate u with respect to v? हमें cos inverse of x को differentiate करना है with respect to under root 1 minus x square. But this expression means what? U, and this expression means what? V. अगर इसको with respect to under root 1 minus x square differentiate करना है, बोले तो क्या? U को with respect to v differentiate करना है. Means we have to find out which value du upon what? dv. We have to, if we are differentiating u with respect to v, means in other word we can say that we are differentiating cos inverse of x with respect to under root 1 minus x square. So now we are finding our required value. Which is our required value? Du upon dv is equal to, we have proved one formula to find out differentiation of parametric function. So here u is equal to cos inverse of x and v is equal to under root 1 minus x square. Means value of u is also in terms of x and v is also in terms of x, means we can say that x is our parameter, and our theorem says that derivative of parametric function can be found out as du by dx, because x is our parameter here, and in the denominator dv upon dx, so which is equals to, now in the numerator d by dx, keep it as it is, just substitute the value of u, which is nothing but cos inverse of x, and in the denominator also d by dx, keep it as it is, replace v by its value. What is the value of v? Under root 1 minus x square, so which is equals to, in the numerator we are finding differentiation of cos inverse of x. What is derivative of cos inverse of x? Minus 1 upon under root 1 minus x square. This is derivative of what? Cos inverse of x. In the denominator we are finding derivative of under root 1 minus x square, which is in the form of under root f of x. So its derivative is 1 upon 2 under root f of x. F of x means 1 minus x square into derivative of f of x. What is f of x? 1 minus x square. So here under root 1 minus x square and under root 1 minus x square will get cancelled. Remaining term in the numerator is minus 1 and in the denominator 1 upon 2 into. Now let us try to find out differentiation of this term. Derivative of 1 is 0, minus keep it as it is, and derivative of x square will be equal to 2x. So here easily we can observe that this 2 and 2 will get cancelled. So remaining term in the numerator is minus 1 and in the denominator is minus x. So which is equal to 1 upon x, because minus and minus from numerator and denominator will get what? Cancel. In this way we have got the value of du upon dv, means our required differentiation du upon dv will be equal to what? 1 by x. Now see in the 9th example, what is the given function? If x into sine a plus y plus sine a into cos a plus y is equal to 0, using this we have to show that dy by dx is equal to sine square a plus y divided by sine a. Now whenever we are applying quotient rule, what is the quotient rule? That derivative of u by v, means derivative of, if the division of two function is there, will be equals to v as it is into derivative of u minus u as it is into derivative of v divided by v square. Means we are getting square of v if we are applying quotient rule. In this expression also square appears, isn't it? तो पहले क्या करेंगे हम यहाँ पे dx upon dy की वैल्यू फाइंड करेंगे कि which value? dx upon dy, then dx upon dy, then dy upon dx can be find out applying this theorem d1 upon dx upon dy, isn't it? So that if we are getting dx upon dy in the denominator, अगर इसका reciprocal किया तो ये v square numerator में आ जाएगा. Getting it? Means to get such type of result we have to make the utilize of quotient rule and this theorem to find out derivative of what? Inverse function. So try to understand here. So that's why we are our denominator should be what? v कौन होना चाहिए? sin a plus y होना चाहिए. तो हम इस एक्सप्रेशन को इस तरीके से सिंप्लीफाई करेंगे कि डिनोमिनेटर में sin a plus y आ जाए. यहाँ पे ऑलरेडी sin a plus y इस एक्सप्रेशन में हम देख सकते हैं. So x into sin a plus y, keep it as it is. This plus term on this side will become minus sin a into cos a plus y. So which implies that x is equal to minus sin a into cos a plus y, keep it as it is. This term is multiplied, on this side it will get divided by sin a plus y, isn't it? Now we have got this term in the denominator. Now we are finding differentiation of x with respect to what? Y. Now we are differentiating this function with respect to y. So differentiate it with respect to y. So derivative of x with respect to y is dx upon dy. On this side minus sin a is a constant term, keep it as it is. Now we are finding differentiation of this term applying quotient rule, means u upon v. According to quotient rule, keep v as it is. V as it is means sin a plus y as it is into derivative, but we are differentiating with respect to y, so write down d by dy into derivative of u means derivative of cos a plus y, minus u as it is means cos a plus y as it is into derivative of v means derivative of sin a plus y. Just simply we have substituted the values in the quotient rule, and according to quotient rule denominator is square of v is nothing but sin a plus y, so square of v. We have substituted the values in the quotient rule. Now minus sin a, keep it as it is. We are finding differentiation of this term. So sin a plus y, keep it as it is. Sin a plus y as it is. Derivative of cos f of x with respect to y will be minus sin f of x. F of x is what? A plus y into derivative of this term will be equals to 1. Derivative of a is 0 and derivative of y with respect to 1 is derivative of y with respect to y is 1. Here minus cos a plus y, keep it as it is. Derivative of sin a plus y will be equal to cos a plus y into derivative of a plus y is 1, because derivative of a is 0 and derivative of y with respect to y is 1. In the denominator keep sine square a plus y as it is, sine square a plus y as it is. So which is equals to, now see here, both the terms are negative. If we are taking minus, or in other word we can say that if I am multiplying by this minus to both the term will become positive. Now if I am multiplying by minus, both the term will become what? Positive. So if I am multiplying to first term, minus into minus will become plus, and sine a plus y into sine a plus y will be equal to sine square a plus y. Again here minus into minus will become plus, and cos a plus y into cos a plus y will be cos square a plus y. In the denominator, sine square a plus y, keep it as it is. Now let us simplify it, which is equal to sine a, keep it as it is. In the numerator, check that the expression is in the form of sine square theta plus cos square theta. Is it equals to 1? So 1 divided by sine square a plus y. Means what result we have got here? Sine a into 1 will be equal to sine a, and in the denominator what we have got here? Sine square a plus y. So this is the value of what? Dx upon dy. Now we are applying our theorem. So we have one theorem to find out derivative of inverse trigonometric function, that is dy by dx is, derivative of inverse trigonometric function dy by dx is equal to 1 upon dx upon dy. So dy upon dx is equals to 1 upon, substitute the value of dx upon dy, which is nothing but sine a divided by sine square a plus y. Just simply we have substituted the value of dx upon dy. So here this term can be shifted in the numerator, sine square a plus y divided by sine a, which is nothing but required value of dy by dx. In this way we have got the required differentiation. Now let us try to solve the last, means example number 10th from fourth part of this question bank. See, in this case one function is given to us, y is equal to 5 raised to power x into x raised to power 5 into x raised to power x into 5 raised to power 5, and we have to find out its differentiation. In case of product, if more than two function appears, at that time we are using what? Logarithmic differentiation method. अगर दो ही फंक्शन का प्रोडक्ट है तो हम प्रोडक्ट रूल से डिफरेंशिएशन फाइंड कर सकते हैं, लेकिन दो से ज़्यादा अगर फंक्शन है प्रोडक्ट में, सो एट दैट टाइम प्रायोरिटी इज गिवन to apply what? Logarithmic differentiation method for simplicity. Differentiation easily find कर सकते हैं हम using logarithmic differentiation method. Applying logarithmic differentiation method means what? Taking log on both sides. So therefore, see what we'll get here. Log y is equals to log of 5 raised to power x, log of 5 raised to power x into x raised to power 5 into x raised to power x into 5 raised to power 5. Just simply we have taken log on both sides. So on this side terms are in the form of log a into b into c into d, which can be written as log a plus log b plus log c plus log d. So here plus log of x raised to power x plus log of 5 raised to power 5. Just simply we have applied laws of logarithm, that log a into b into c into d can be written as log a plus log b plus log c plus log d according to laws of logarithm. Again let us simplify it applying laws of logarithm. This coefficient power can be taken as coefficient. So here we will get x log 5 plus, here also if we are taking power as an coefficient, here we will get 5 log x, here we will get x log x, and here we will get 5 log 5. Now differentiate it with respect to x. So differentiate it with respect to x. On this side derivative of log y is 1 upon y into derivative of y means dy by dx. It is in the form of log f of x. What is derivative of log f of x? 1 upon f of x is y into derivative of f of x means derivative of y is dy by dx. On this side derivative of x is 1 and log 5 is a constant term. So 1 into log 5 will be equals to log 5 plus 5, keep it as it is. What is derivative of log x? Will be 1 by x plus, here to find out the differentiation we have to apply product rule. According to product rule, first term as it is, derivative of second term, it means derivative of log x plus second term means log x as it is into derivative of first term. What is first term here? X. So here we have applied product rule. First term as it is derivative of second term plus second term as it is derivative of first term. And if you will observe the last term, is it a constant term? Because x does not appear in it. So and derivative of constant term will be equal to 0. So derivative of last term will be equals to 0. So therefore dy upon dx will be equals to, so y will get multiplied on this side. On this side, write down this expression in the simplest form. Log 5 plus 5 into 1 by x will be equal to 5 by x plus x, keep it as it is. What is derivative of log x? Derivative of log x is 1 by x plus here log x, keep it as it is. Derivative of x will be equals to 1, not necessary to write 0. So this implies that dy upon dx will be equals to y. Replace y by its value. What is the value of y? 5 raised to power x into x raised to power 5 into x raised to power x into 5 raised to power 5. Just we have substituted the value of y. Write down remaining expression as it is. Here we will get log 5 plus 5 upon x plus xx will get cancelled, we will get 1, and here we will get log x into 1 will be equal to log x. In this way we have got the differentiation of this function applying logarithmic differentiation method. So in this way we have completed fourth part of the question bank. In the next video we will discuss the last part, fifth part, and important 3 theorems from the differentiation, because one theorem from these 3 theorems always can be asked either for 3 or for 4 mark in the examination. So last lecture is very important lecture in which we are discussing fifth part, means the question which can be asked for what? 4 marks, and even 3 important derivatives also. So if you think that these videos are very helpful to you, so please like the videos and share these videos with your friends also.